Pluto is a distant and icy dwarf planet that was once considered the ninth planet in our solar system. It orbits the Sun far beyond Neptune, and its small size and remote location made it hard to study for many years. Though it was reclassified as a dwarf planet in 2006, Pluto still sparks curiosity among scientists and space enthusiasts alike. Recently, attention on Pluto has grown due to statements from astrophysicists like deGrasse Tyson and Michio Kaku. They have reignited public interest by discussing the theoretical idea that Pluto could one day be on a collision course with Neptune. While that sounds alarming, it's more complicated than it seems. The idea of a Pluto-Neptune collision might sound like science fiction, but it has its roots in real science. Pluto's orbit is highly elliptical and tilted by about 17 degrees, unlike the almost circular orbits of other planets. This unusual orbit brings Pluto closer to the Sun than Neptune for about 20 years in each orbit. However, despite this overlap, Pluto and Neptune have never collided. The reason lies in what scientists call orbital resonance. Pluto and Neptune are in a 3-to-2 orbital resonance, meaning for every 2 orbits Pluto makes, Neptune completes 3. This precise ratio prevents them from being in the same place at the same time. This gravitational relationship acts like a cosmic safety mechanism. Whenever Pluto is closest to the Sun and near Neptune's orbit, Neptune is always far away. The two objects are always at least 90 degrees apart in their orbit, so a collision simply doesn't happen. Another stabilizing factor is Pluto's orbital inclination. Because Pluto's path is tilted, it passes either above or below Neptune's orbital path, adding another layer of separation between them. These factors combine to create a stable but complex orbital dynamic. Scientists have studied Pluto's orbit using numerical simulations. In the 1980s, researchers ran simulations that showed Pluto's orbit remains stable over millions to billions of years, even though it can appear chaotic. These simulations are based on the three-body problem, which studies how the Sun, Pluto, and Neptune interact. Understanding this complex relationship helps scientists predict future orbital changes. Despite Pluto's chaotic behavior, it's held in check by gravitational forces from multiple planets, not just Neptune. Jupiter and Saturn also play a role, exerting powerful gravitational pulls that influence Pluto's movement. Neil deGrasse Tyson has addressed the curiosity around Pluto's orbit, emphasizing that while Pluto's path looks unstable, it's actually a well-balanced cosmic dance. Tyson was one of the leading voices in Pluto's reclassification, stating that our solar system contains many similar objects, and science should be based on clear definitions. Michio Kaku also weighed in, stating that although a collision is unlikely, the interactions between planets show just how sensitive and dynamic the universe can be. Both experts agree that studying Pluto helps us understand larger patterns in celestial mechanics. Another interesting concept is the VSK wobble, named after researchers who studied gravitational tugging between celestial bodies. This wobble is a subtle, repeating shift in Pluto's orbit caused by the combined pull of Neptune and the Sun. Despite appearing random, it helps keep Pluto's orbit stable over time. This brings us to the idea of orbital chaos. Pluto's path is sensitive to its starting position, speed, and the positions of other planets. Small changes in these conditions could lead to vastly different outcomes. Yet, Pluto has managed to stay in a safe orbit, thanks to these intricate gravitational balances. Pluto's journey around the Sun takes 248 Earth years. Since its discovery in 1930, Pluto hasn't even completed one full orbit. This long orbital period adds to the mystery surrounding its future. Will it remain on its current path, or could unseen forces shift its trajectory? Some scientists believe that external forces like a passing star or the hypothetical Planet 9 could disturb Pluto's orbit. Planet 9 is believed by some to exist in the outer edges of our solar system. Its gravitational pull could potentially push Pluto into a new path, altering the delicate balance it currently shares with Neptune. The existence of Planet 9 is still uncertain. No telescope has detected it yet, but calculations based on the movement of other distant objects suggest something massive could be hiding far out in space. If real, Planet 9 could change our understanding of how outer solar system objects behave. Another factor that might affect Pluto and Neptune's relationship is the Sun itself. As the Sun ages, it gradually loses mass through solar wind. This process can slowly cause the orbits of planets to expand over time, slightly altering their positions and distances. Even small changes in the Sun's mass can have ripple effects across the solar system. It could eventually cause Pluto's orbit to drift, possibly disrupting the 3:2 resonance with Neptune. While this wouldn't happen soon, it's one of many variables scientists keep in mind. The outer solar system is also filled with comets and smaller objects that can occasionally pass close to Pluto or Neptune. These bodies, though tiny compared to planets, can still exert enough gravity to make a difference over long periods. This makes the region constantly shifting and full of hidden influences. With new technology, scientists are now able to run better simulations and collect more accurate data. Each new discovery adds another piece to the puzzle. What looks like chaos may actually be a pattern we just haven't fully understood yet. Pluto's strange orbit is a window into the unknown. It's a reminder that our solar system is still full of mysteries. The way its orbit stays balanced despite all these variables is not just fascinating, it's also crucial to our broader understanding of how planetary systems form and evolve. If Pluto and Neptune ever did collide, which is extremely unlikely, the results would be enormous. Neptune is a gas giant, made mostly of hydrogen and helium, while Pluto is a rocky, icy dwarf. A collision would release huge amounts of energy, create shockwaves across the system, and likely leave behind new debris or even moons. Subscribe to our channel and thanks for watching.